Welcome everybody. In this question, we're going to find the shaded area. Okay, below the curved line, integral will help us find the area. So integral from -1 to 2. We know the equation of the curve, which is x to the power of 5 minus 2 x squared plus 9. Then, okay, right now let's integrate. We're going to have x to the power of 6 divided by 6 new power minus 2 times x cubed divided by 3 plus 9x. Our boundaries in between -1 and 2. S2 and -1. We're going to replace 2 with x. Then we are going to subtract or take away after replacing -1. So let's try it right now. 2 to the power of 6 divided by 6 minus 2 times 2 cubed divided by 3 plus 9 times 2. We take away after replacing -1. So -1 to the power of 6 divided by 6 minus 2 times, yes, let's fix there, minus 2 times -1 to the power of 3 divided by 3, -1 to the power of 3 divided by 3, plus 9 times -1. That's it. We are going to take away right now. Okay, we'll have 32 divided by 3 comes from the first brackets, minus 8 over 3 plus 18. And from the second brackets, we have minus 1 over 6 plus 2 over 3 minus 2 over 3, because the minus sign will affect the brackets. So we're going to have 9 there. After calculating, we are going to have 63 divided by 3. So 63 divided by 2 will give us the shaded part. Now I'm going to show you this area below the curve. This integral will give us the area, which is 63 over 2. Okay, right now I'm going to draw a trapezium because it's gonna help us to find the shaded area. After finding the area of the trapezium, I'm going to subtract or take away the area, the result of the integral. Then I'll find the shaded, the gray area. So at first, I need to find the area of the trapezium. So to find the area of the trapezium, so to find bottom and top side, I need to replace x with 2 and -1. After that, I'm going to find these lengths. So this top of the trapezium, this is the top of the trapezium. So to find the length of the top, we need to find the value of y coordinates. So if I substitute x equals 2 in this equation, x to the power of 5 minus 2 times x to the power of 2 x squared plus 9. This is the equation of the curve. So after substituting x with 2, I'm going to have, and calculating this, and I'm going to have 33. So the y coordinate is 33. So the length of the top side, let's say top side, which is 33, and I'm going to find the bottom side. So if I substitute x with -1, or if you replace x with -1 in the equation, what we have here, x to the power of 5 minus 2 times x squared plus 9, which is the equation of the curve. If I replace there x with -1, and I'm going to see that I'm going to find the length of the bottom side, let's say. So let's replace here. So -1 to the power of 5 minus 2 times -1 to the power of -1 squared plus 9, which is going to be 6. So this is the length of the bottom side. and we find the length of the bottom side and the length of the top side of the trapezium. So right now we can find the area of the trapezium. You know, we know the height of the trapezium. If you put the trapezium on its bottom side, let's say, which is 33 right now, if you turn the trapezium and put it on bottom side, which is 33, so we see that the length or the height of the trapezium will be 3. And to find the area of the trapezium, we are going to add bottom side and the top side divided by 2 times the height, which is 3 in this question. Looking at the distance between -1 and 2, which is 3. After that, we find the area of the trapezium, which is 117 divided by 2. So this is the area of the trapezium, and we know the area below the curve, which comes from the integral. It is 63 divided by 2. We find the area of the trapezium first. Second, we find the area coming from the integral, which is 63 divided by 2. Finally, what we're going to do is just taking away the result of the integral from the area of the trapezium. Right now, I would like to show you how I'm going to move the area of the trapezium, and I'm going to place on the coordinate plane, let's say. So let me copy this first, and you're going to see that I'm going to move it there. After taking away the area of the integral, I'm going to find the gray area. You'll see it, guys. Let me copy it and paste there. Hold on, I'll take it and put there. You see that the area of the trapezium, if I subtract the result of the integral, I'm going to find the gray area. Finally, I'm going to subtract or take away the area below the curve, which comes from the result of the integral. So 117 divided by 2 minus 63 divided by 2, which is gonna be 27. The result is 27, guys.